Hello, 11th graders. So we are moving on from our just analysis aspect of learning about trigonometry. So in the last notes, you learned about, okay, how do we apply right triangle trigonometry just to triangles, not even really applying it to the real world. But we are in an applications class. And so most of your SOHCAHTOA, your right triangle trigonometry, is going to show up in an application. And so here are some applications in which you will see these concepts, these skills, these processes show up as a progression. So the very first thing that we have is something called angles of elevation and angles of depression. All it is in a nutshell is how you're looking at something. If you look up or if you look down, you can calculate distances on how far you look up compared to like how tall you are or how far away you are from something. This is very, very common in the real world. If you're talking about navigation on ships, they use something called a sectant, and the sectant measures the angle of elevation to a certain star, and depending on where you are in terms of the astronomical process of the stars in the sky, depending on where you're at in relation to all of that, you can then figure out how far you are from a certain part on the globe, right? So angles of elevation, angles of depression, you're going to see it in kind of like baby steps, but just realize that going down the angles of elevation and depression rabbit hole can lead you to some really, really cool things that are used every day in all around the world. All right, so angles of elevation. The main idea, let's draw a hill. The main idea is you've got a measurement of something. This is my beautiful tree. You've got something that you are trying to find like a height of or how far away you are, and it always involves a person. And this person is always either looking up or looking down. Angles of elevation is looking up. Angles of depression are looking down. Now, when you're told about this, first, always draw a picture. It doesn't have to be beautiful. I know you guys will all aspire to draw as beautifully as I do, but it doesn't have to be beautiful. It doesn't even have to be descriptive. It could just be a stick to represent a tree. It could just be a dot to represent a person. Okay, so it doesn't have to be descriptive. Just have a picture that represents the situation. So you're given a problem and you're told you have an angle of elevation or an angle of depression. The first thing you should do, if you're not paying attention, pay attention now. The first thing you need to do, always, is draw the horizontal line. There is a horizontal line that needs to be drawn from the person's eyes. And this does matter that it's from their eyes, because sometimes they'll be like, this person is 1.5 meters tall, or maybe they're looking out from a window that is like 10 meters up in the air. And so that matters because it'll change your dynamic of the picture. So it is from the line of sight. You need to draw a horizontal line. And then you draw the actual line of sight. Now, this is where we think about elevation or depression. Are we going up or are we going down? So the angle of elevation would be going up to the top of the tree. So this is elevation. The angle of depression would be going down to the bottom of the tree, which means that this angle right here is the angle of depression. The third thing that you do is find the right triangles. Once you have the right triangles, then you can begin solving. So notice here that if we drew in a vertical line, I now have all the information I need in order to find the height of the tree, because the vertical and the horizontal line are going to be perpendicular. So now I'm talking about right triangle trigonometry. So let's maybe say that I knew that I was this far apart, or maybe I knew that I was on a hill that was 2 meters tall. And so then I would know that this guy is 2 meters. So you're always given some sort of linear measurement with your angles of elevation and angles of depression. And you can use that linear measurement and the angle to then solve for any part of the right triangle that you might want to solve for. So this is angles of elevation and depression in a nutshell. Let's go ahead and put it into practice. We've got the Burj Al Arab luxury hotel in Dubai. It's in the United Arab Emirates. It's located on an island that is 280 meters from the Dubai beach. So that's important. I don't really know why yet, but I know it's important, so it's sticking in my mind. Maybe I highlight it. Maybe I underline it as like, that's some information I'm going to use. A land surveyor who is 1.78 meters tall. So again, going back to this idea that sometimes you're given the height of somebody and it does matter. Standing on the shore of the Dubai beach, measures the angle of elevation to the roof of the building to be 36.6 degrees. How tall is the building? Now that you finished reading it, let's try and get a general idea of what's going on. I'm going to show you that you don't even have to have very descriptive pictures. This is the person, and this is the building. Okay, so we know that the land surveyor is 1.78 meters tall. So I'm going to say that that is 1.78. We know that the island has this building, which is this many meters away from the beach. So we know that the land surveyor is 280 meters away from the building. And we know that his angle of elevation is 36.6. I first need to draw in my horizontal line. And then I can draw in my angle of elevation. This guy is 36.6 degrees. I know that this is a right triangle, and I know that this measurement can move up to meet up with my right triangle up here. So I know that that is 280. Now the thing here is that I want to solve for the height, the total height. But your land surveyor is 1.78 meters tall. This is 1.78. And your right triangle is going to give you this distance. So just keep in mind, and you should absolutely write this somewhere at the beginning, that x is equal to y plus 1.78. That it's both of those distances added together. Okay, so what we want to make sure to do, we need to make sure to write this down, because if you go really deep into the okay, I need to build my right triangle trigonometry. Okay, this is going to be this trig function. Then you start going and then you solve for y and you're like, yes, I did it. And then you want to move on, because you forget once you delve into these processes, you forget that you have something else that you need to do at the end. So this is a great reminder. Oh, I'm not done yet. Okay, so first I need to solve for y, and then I need to solve for x. All right, now we go into the SOHCAHTOA aspect of this problem, of this dilemma. So I want to solve for the opposite side length of 36.6, and I have the adjacent side length of 36.6. O and A, if you need to write SOHCAHTOA at the beginning of every problem to visually see, O and A is tangent. If you need to do that, write it out every single time. All right, so we know that we need to use tangent. So tangent of 36.6 is equal to, and it's your opposite, over your adjacent. We can use our numerical solver to solve for this guy. I'm going to go into here. Remember, you click Menu 3, Numerical Solve. If you have a TI-84, talk to me at the beginning of class when you see me and say, show me how to do numerical solver on a TI-84, and I will show you how to do it. Right now, I'm just going to show TI-Nspire always. Or you can pause the video right now and Google numerical solve TI-84, and there is about 20 nerds on the internet who want to show you how to do it. All right, so we're at numerical solve. We want to solve for this guy right here. So I'm just going to start plugging it in. I've got tangent of 36.6 equals y divided by 280. Now, don't forget, you need to put in the comma and say, hey, calculator, I want you to solve for y. So you do comma y, and then you press enter. y is equal to 207.946. We'll do 3 significant figures because it doesn't tell us, so we'll do 208 meters. Oh, except for that is not our final answer, so we probably shouldn't round now. And as always, it's really easy to get lost in the process because now we need to take this guy and we need to add 1.78. So I'm going to just do plus 1.78. X is equal to 209.726, which means that X is equal to 210 meters. And there we go.